Okay, this video I want to talk about dimension. I want to take you through dimension. Okay, so we need to now look at the concept of dimension. What is it? So dimension always has to do with a physical quantity, any quantity that can be measured directly or indirectly, or any part of matter that can be quantified directly or indirectly. This is a physical quantity. So there are basically 7 fundamental quantities, and a few of these are put together to obtain derived quantities. So most of the fundamental quantities have their dimension, and then most of the derived quantity also have their dimension. So now let's look at what is dimension in terms of definition. What is dimension? So quickly, dimension is the, let me put it well. So dimension of a physical quantity is or are those powers, let me put it right, are those powers to which the fundamental quantities so that's I here, fundamental quantities are raised to express the quantity. Okay, so this is the definition for or to express that quantity. Let's make it right. Okay, so this is the definition for dimension. So basically, let's look at the few dimensions we have. So the dimension we have, so basically we have some fundamental quantities and their dimension. So we start with mass. Mass has a dimension of m, capital M, and then we have time. It has a dimension of capital T, and then we have so we have mass, we have time, and then lastly, not lastly, but we also have length. Okay, so length it has a dimension of capital L. We have temperature, so let's use this. Temperature has a dimension of K, and then a few of them are also there. But now let's look at this few, just for us to understand, and later we can do a deep discussion on the rest. So these are the, let me say, the 4 basic fundamental quantities that we have, and then these are the dimension allocated to it. So when you pick any physical quantity, you would like to allocate its or try to find its dimension. So let's start something like area. So first of all, look at the quantities that come together to form area. So we have length, we have length times breadth, or length times width. This gives us area, and then these are all in terms of length. So we have L times what? L, and then its dimension will be equal to L square, and we always put it in a square bracket. So the dimension for area is this. We have volume, So first of all, you have to look for the formula that comes, or the dimensions that come together to give you volume or the physical quantity you are talking about. And when you're able to get it, you just have to find its dimension and express it as how many of it do we have in that quantity. So we have here length times what, breadth times what, height, and they are all in terms of length. So we have L dot L dot what, L, and this will give us L to the power 3. We put it in a square bracket nicely. We come to area. So now let's look at speed. So speed is distance over time. Distance over time. So distance over time. Distance is in terms of length. So L, and then we have capital T. This will now be equal to L, because this one is divided. When it comes up, it has a power of -1. So -1, and then we put it in a square bracket like we've done nicely. Now let's look at velocity. Velocity. Okay, so velocity has the same dimension as speed. The reason is that for velocity, it is displacement, and displacement also comes in terms of length. So displacement over time, sometimes we can represent it by s over time, and this is equal to L on t. So its dimension will be L t to the power 1, and we put it in a square bracket. We look at acceleration. And then its dimension is, so acceleration has a formula of velocity over, so change in velocity with respect to time, and this will be equal to, so we already know velocity is what, lt neg 1 all over what, t, sorry, capital T. So this will be equal to lt neg 1 dot neg 1. So we'll put everything together, and this will give us lt neg 2 in a square bracket. So this is the dimension for acceleration. We can talk about force. So force has a formula of ma, that is mass times acceleration. We already know the dimension for acceleration, so we are going in that order so that it will be very simple for us. So the mass has dimension of m, so m, then we bring this one lt -2, and then we'll put it in a square bracket. So this is the dimension for acceleration. This is the dimension for force. This is the dimension for speed, velocity, and the speed. We have volume, and then we have area. The dimension for length is L, so we already know that. Okay, so let's look at a few of it and see a few. So now that we are okay with the definition, if you want it, you can just go back and you will get it. Okay. So now let's consider a few of the quantities. So we have a quantity like work, and then energy have the same dimension. Okay, and the formula is length times force, or let's say distance. Let's put it well. So the force applied to move something through a distance of in this case d. So this is the formula for work or energy, and this is equal to, so we know that the dimension of force to be lt neg 2, put it in a square bracket, and then we know that of what, distance to be L, so all will be equal to m L square t neg 2, put in a square bracket, and that is our formula or our dimension for force. So there are a few of this here. Then we have that of power. We have power. So power has a formula of work over time. So the rate at which work is done, the rate at which energy is being transferred is no, we already know that of work, which is m L square over neg 2 over what? T, and then we know T to be what? T on just T. So when we bring the T up, we'll have M L square T neg 2 dot what? Neg 1, and this will be equal to final answer will be equal to M L 2 neg 3. This is the dimension for force. So always just look for the formula of the quantity you are looking for, and when you have the formula, you'll be able to obtain the dimension. We have strain. Strain has a formula of change in L over L. So change in length of a metal, anything, and then the original length. And this one has a dimension of L over what? L. So they will cancel out. So strain has no dimension, it's dimensionless. Dimensionless. Okay, so that is strain. Then we have density. So density has a formula of mass over volume. We know that of mass to be M, volume to be L to the power 3. Okay, so when you bring everything up, we'll have M L to the power 3. You put it in your square bracket and you are good to go. Then we have another, this in momentum. We can talk about momentum, which is equal to velocity times what? Mass. We know velocity to be lt neg 1, and then our mass is this. So momentum will be equal to m lt neg 1. We put it in the square bracket and we are good to go. So that is how we go through all the other formulas to get a rest. Now let's look at the last one, that is pressure. Pressure has a formula of force over what? Area, and then we know the dimension of force to be in this case we have dimension of force to be L M L T neg 2 all over area, which is L square. So this will be equal to this will come up. Okay, so when it comes up, we have capital M L T squared dot L to the power negative 2, and this will be equal to, because you have the, so take one of the base and then one here, negative 1, which will give us negative 2. So you have M L to the power negative 1 T to the power 2. You put it in a square bracket, and that is it. So dimension can be used for a whole lot of things. It can be used for. So now in the next video we'll look at application of dimension, and then how dimension can be used to obtain a unit for a quantity, how dimension can be used to validate the accuracy of a formula, and then we can also use dimension to obtain an equation for a certain quantity. So that is it for this video. Thank you. Please subscribe, click the notification button so that anytime I post in new videos you have access to it automatically. That is it for this video. We'll see you in the next one.